to talk today about how to decode resistors. There's a bunch of samples in a box on the cupboard. Otherwise, I left a few up by the document camera. If you want to take a look at, what resistors look like, they're a tiny little piece of wire with some um, clay or porcelain or something in the middle. Anyway, they're so small you can't, really write on them very well or even read it. So back in the day, they just put colored stripes on them so you could decide what the resistance was on those resistors. So you have this color screen here, and you guys got that page before. Nope, not that one. There we go. And you just go through and decode what the colors are. So black means 0 if it's in the first band on the left. The second band is red, and that means 2 if it's in the second band. We're actually not going to do anything with the third band on any of the resistors that we have because, well, it's kind of overkill for my purposes here, or for your purposes as a tech math. And then the third band is the multiplier, which in this case, green, is times 100,000. So it's just about that simple. And but now we have to do a little bit of math with this now, since it is a math class. So first step, just take the colors and write them down. If you have a gold stripe, the last band is the tolerance. And the reason that I took chapter 14 before I took chapter 12 was so that we could go through and do these percentages a little quicker. So gold band is 5%. So the next step is to just write this thing in standard notation. So 0 plus 2 is 2, times 100,000 is 200,000. Plus 2. That's not the right answer. This is like the tens place, and that's the ones place. So it's 2 times 100,000 is 200,000. So just write it in standard notation. Then we're going to write this in engineering notation, which is kind of my purpose. The decimal point sitting over here. Move it to the left until it gets to so that that number is between 1 and 1,000. And that makes this, in engineering notation, 200 times 10 to the third. And then here we go into the SI prefix, which is you look up 10 to the third on this chart. Okay, so then you would look up 10 to the third on this chart over here. And 10 to the third has the prefix kilo. So we'd call this a 200 kilo ohm resistor. So we would abbreviate that 200 K ohm, and you guys remember from your science class that, or maybe you don't, the Greek letter omega stands for ohm, and plus or minus 5%. So, when you go to buy these in the store, you'd get a bag, it'd say 200 kilo ohm on it, and it'd be filled. There wouldn't be any other numbers on any of these little resistors. But the reality is that even though it says it's going to be 200 kilo ohms, when I get back, I'll show you guys how to ohm these out and how to test them. It might be something a little smaller than 200, a little bit more than 200, because it's not a perfect world. And because I want to review exponential growth and decay, let's talk about how that's going to work. So here we go. This plus or minus 5%. 100% plus 5% is 105%. So it's kind of like those exponential growth questions we just got done doing last chapter. Take 200 kilo ohms times 1.05, and you're going to wind up with 210 kilo ohms. So even though the wrapper says it's 200 kilo ohms, when you actually go to use it in something electronic, it's going to wind up being more like 210. Or it could be as big as 210 kilo ohms. Same deal with the minus business. 100% minus 5% is 95%. So if I take 200 times 0.95, I wind up with 190 kilo ohms. So even though the wrapper says 200 kiloohms. Um, when you go to put it in something electronic, it might be as low as 190 or as high as 210 kiloohms. So there's three answers you guys have to do for this worksheet. Um, you have to tell what the colors say it is. So black, red, green means 200 kiloohms. And then the second part is um, you have to do the tolerance, which basically says if it's less than 190 or more than 210, you should throw it away because it's out of tolerance. Okay, so let's practice another one here. Blue, yellow, silver. You just come over here. Uh, blue is 6. Yellow is 4. Silver, if it's in the multiplier band, is times 0.01. And silver, if it's in the fourth band, is times 10%. Plus or minus 10%, sorry. So then we just write that in standard notation is 6.64 when I multiply these two out, 0.64, and then that's going to be plus or minus 10%. That's your standard notation. Then remember, if it's going to be in scientific notation, we have to make sure that this number is between 1 and 1,000. So I'm going to move my decimal point over here. Got to move it 3 spaces. And in engineering notation, that's going to be 640 times 10 to the negative third. Again, 0.64 is pretty small. So if I take 640 times 10 to the negative third, that's going to shrink the answer down. Plus or minus 10%. I gave up on trying to write these things with the mouse. So here I am typing. Then we take that thing and we write it with a prefix. You come over to here on your formula sheet and look up 10 to the negative third, which the prefix there is milli. So using the SI prefix, we would call that 640 milliohms. Now we have to deal with the plus or minus 10%. So I'm going to take, if it's going to be 10% plus 100%, I'm going to take 640 times 1.01, which gives me 740 milliohms, and I use this little abbreviation right there. I use the symbol point or little m. And just continuing on, I have to do the minus 10%. So 100% minus 10% is 90%. So I'm going to take 640 times 0.90, which is going to give me 640 milliohms. I'm sorry, 576. So 640 times 0.90, 576 milliohms. So you need 3 answers for these. The first answer is the coded one with the SI prefix. And then you need to know, even though the bag says 640 milliohms, you have to know it could be as small as 576 or as big as 704, if that's the particular resistor you have. So nice little review of engineering notation, standard notation, which, engineering notation is kind of like scientific notation, SI prefixes. And again, when I get back, we will talk about how to use the multimeter on these. Have a good day.